everyone, welcome to week 7 of ICS 111. This week we are going to be learning about loops. So these will be our while loop, do while loop, and for loop. Okay, so if you remember a very long time ago in week 1 of this course, we talked about computers and why they're so valuable to us. So one of the things that we discussed is that computers are really great at doing things over and over and over and over again, and they don't complain, they just do it all for us. Okay, so one of those things that we could make computers do is to just perform calculations over and over again. So usually we have computers perform the same calculation. This can be a simple or a complex calculation, but even if it's simple, remember that even if it's something as simple as add 1 to this number, add 1 to that number, then add 1 to that number, then add 1 to that number. I mean, it's really simple. We could easily do that, but would we want to do that? Would we want to do that if we had to do that 1,000,000 or 1,000,000,000 times? No, we have better things to do. Okay, so that is an example of something that we can make computers do for us. Another example is to have them print the same thing over and over again, either the same exact thing or maybe have them change things slightly each time they print it. So to accomplish this, in order to make computers do things over and over and over again for us, we use something called loops. And what loops do is that they repeat lines of code. Okay, so the types of loops that we will be looking at are the while loop, the do while loop, and the for loop. So we're going to start by looking at while loops. So just to visualize what sort of happens in a while loop is going to repeat your code as long as a condition is true. So remember last week when we talked about if statements? We said if this condition is true, then do this code. Well, while loops are kind of the same idea. Okay, so we're going to say, while this condition is true, do this code right here. And then after doing that code, go back to the condition and check it again. Is this condition true or false? If it is still true, go back and do that same code over again. And then after that, we're going to go back and look at the condition again. And we're going to ask, is this condition true or false? And let's just say that it's false. So we're going to say it's false, and we exit out of that loop, and we continue on with our code. So this is what a while loop is going to look like. You're going to have the while word. This is a Java reserved word or keyword. And then you're going to write the condition. You're going to put little curly braces, and in here is your loop body. So the loop body is the part of the loop that contains the statements or code that you're going to be repeating. And each time that this loop is executed, we call that an iteration. Okay, so if you'll notice, this actually does look very similar to our if statements. So remember, we had if this condition is true, then do this code. Whereas we have here, while this condition is true, do this code. Okay? So speaking about the condition is going to be a Boolean expression, which means that it's going to evaluate to either true or false, and this is going to control whether the loop body will be executed. Alright, so it is evaluated each time to determine whether or not the loop body will be executed. So if you remember the little visual graph where every time we did the loop body, then we went back to the condition and we decided, is this true or false? If it's true, run the loop body again, and then look at the condition again and see, is this true or false, etc. Okay, so if the evaluation is true, the loop body is going to be executed. And if the condition is evaluated to be false, then the entire loop is going to terminate, and we just continue on with your code over here. Okay? When writing while loops, what you're going to need is, first of all, this Java reserved word or keyword, and it is while, because remember, with our keywords, when you write them, the Java compiler expects that you are doing something very specific. So when you write while, then it is expecting you to create a while loop. Okay, so aside from writing while, we're going to need three things. First of all, we're going to need the condition. So the condition is going to be that Boolean expression that evaluates to either true or false. And then we're going to need something called your initialization expression. This is your starting point for the loop. Basically, you're creating some sort of basis so that the loop is able to start running. Okay, you'll see what that means in a second. Finally, you need something called the modification expression. This is a statement that modifies the initialization expression so the condition will eventually become false. Okay, so in other words, this modification expression is going to change the condition so it's eventually false, because remember our if statement, for example, we said if this thing is true, then do this. Whereas with while we say for as long as this condition is true, then keep doing this and keep doing this and keep doing this. Keep looping around until the condition is eventually false. Well, to eventually make the condition false, we need this modification expression. Okay? Alright, so here's a little more closer look at the while syntax with those three parts. So we have our initialization expression first. Okay, you're going to need to write this before you even write your while loop, because as we said, this is the thing that creates the starting point for the while loop. We need it in order to create our while loop. And then we're going to write our keyword while, and we're going to insert our condition, and then we have our loop body. So first of all, please remember Java coding standard, the code in the loop body should be indented. And then you're going to be writing your modification expression inside this loop body. And remember, we need this modification expression inside because statements inside here, all this code over here, is going to keep on repeating as long as this condition is true. Okay, so let's look at an example. Here we have, first of all, our initialization expression. So we're going to create a variable. It's called counter. It is of integer data type. It has the value 1. You create another variable of integer data type named limit, and we assign it the value of 3. And then we also are just going to create a string. We're going to call it hello, and it just has the string hello. And then we're going to write while, and here is our condition. While counter is less than limit, so it's going to consider, is counter less than limit? Is 1 less than 3? Well, yes, it is. So because this is true, 1 is less than 3, it's going to do this code right here. It's going to print out hello. Okay, so let's just take a look at these individual parts. So first of all, we have these initialization expressions, As we noted, they do act as a starting point for the loop. So if you'll notice, we have this counter variable, we have this limit variable, and right here, we use that counter and limit variable for our condition. So we need to initialize these variables before we can use them here. All right, and now here is our condition. So we are using our comparison operators to evaluate whether this whole thing is true or false. So please remember your comparison operators. They are from week 2. You use them for week 4, 5, 6 probably, the assignments. And we also reviewed them when we went over if statements in week 5. So please refer to the week 2 and week 5 slides if you're still unsure about what comparison operators are. But basically, just as a quick review, they're the things that allow us to ask, is this less than? Is this greater than? Is this less than or equal to? Is this greater than or equal to? Is this equal to? Or is this not equal to? Okay, so please make sure you remember those. And then we have this loop body. This is a code that is going to be repeated every time this condition is true. All right, so do you think our code looks great? Is this a perfect example of a while loop? Well, not exactly. Okay, so in the loop body, there is no modification expression. Therefore, the condition will always evaluate to the same thing. Remember, the modification expression is going to affect the condition to eventually change it so we can get out of our loop, okay? So in this code, the condition will always be true because it says while 1 is less than 3, well, 1 is always going to be less than 3, so therefore it's actually going to repeat infinitely. We actually call it an infinite loop. So let me just show you really quick what that looks like. All right, so we're going to say int counter equals 1, int limit equals 3, and we're just going to create our string that says hello to us, and then we're going to create a while loop. While counter is less than limit, we're going to print this string, and don't forget your closing curly brace. Alright, so let's see what happens when we do this. We're going to run it, and if you notice, it is just continuously repeating itself. It's just continuously doing this code. Hello. It's printing out hello, 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 and on and on forever. There is no way that I can stop my program from doing this because we are stuck inside this while loop, because it's going to say while counter is less than limit, while 1 is less than 3, print this. Well, nothing is ever changing that 1 is going to be less than 3, that counter is going to be less than limit. So we have an infinite loop, and it's just going to keep on printing. I could keep my computer on for the next million years, and as long as the computer continues to run, this program will continue to run. Okay, so make sure that you are aware of infinite loops. Make sure you have some sort of modification expression that is going to keep your program from creating an infinite loop. So let's try again. Okay, so in this example, what we're going to do is we're going to have this thing right here, our modification expression, and it is going to change the value of counter. So do not write this code in yet. Let us do this together so we can go through it step by step. All right? So first we're going to have our while counter is less than limit, print hello, and then add 1 to counter. Okay, so here is a little table that's going to show you the steps. We have counter it's initially equal to 1, and of course limit is equal to 3. So the first time we run our while loop, we're going to say, is 1 less than 3? Well, yes, 1 is less than 3, true. So print hello. And then increment the value of counter by 1. So 1 plus 1 is equal to 2. And now counter is equal to 2. And then we ask, is 2 less than 3? Yes, true. So because it's true, we're going to run the code inside the while loop, print out hello, and then add 1 to counter. So 2 plus 1 is 3. Is 3 less than 3? Well, no, that's false. So we're done. We're out of our while loop. It's done, and we continue on with the rest of our code. Okay, so think about how many times this will loop, and what is the value of counter at the end, and what does your output look like? Okay, so think about that for a moment. Pause the video if you wish, and then let's look at what happens. Okay, so we know that it's going to loop through twice because the condition is true twice, and at the end counter is equal to 3 because we get to 3 but it hits false and we're done. So this is what our output will look like with a modification expression. So now we're saying while counter is less than limit, print hello, and modify counter by adding 1 to it. So eventually it will not be less than limit and we can get out of this while loop. Okay, so let's run this, and it prints out hello twice. Okay. Here is another example. So let's say we have int counter is equal to 5. I'm going to put my limit to 9, and I'm going to have some char variable called chk, and it's just going to be an exclamation point, and we're going to say while counter is less than limit, print check. And remember this thing that we did? I hope you remember it, because this is our increment operator. We reviewed it for week 2. It was extra credit on your midterm last week, so please remember what this does. If you don't remember, all it does is it's going to increment counter by 1. So the previous code we had was this, and that is actually the same thing. Here we are going to say counter plus 1, and here we increment by 1. Okay, so we're going to just say counter plus plus because it's simpler. And so let's go through what happens first. Do not run your code. Let's just go through the steps together again. Okay, so it says while example number 2, what is the output? So we have our initialization expression over here, and we say while counter is less than limit, then we're going to print out this exclamation point and increment counter by 1. Okay, so let's go through the steps. In this tail over here, you can see our limit is 9, and our counter, well, it starts off at 5. So it's 5 right now. We're going to say, is 5 less than 9? True. Print this out, increment up by 1. So now counter is equal to 6. Is 6 less than 9? True. 6 is less than 9, so print out another exclamation point. And then, let's see, increment counter by 1. So 6 plus 1 is equal to 7. Is 7 less than 9? True, it's less than 9. So we're going to print out another exclamation point and then increment counter. And then that is now going to give us counter is equal to 8. So we'll ask, is 8 less than 9? True. So print out another exclamation point and then increment counter. 8 plus 1 is 9. And we ask, is 9 less than 9? Well, no, it's false. So we're done. We're out of our while loop. This is now false. we can continue on with the rest of our code. Okay, so what that's going to look like, let's just do print so you can see it all on one line, and let's go. Alright, so we had counter is equal to 5, print this exclamation point, counter is equal to 6, so true, print this exclamation point, counter is then equal to 7, print this third exclamation point, counter is now equal to 8, print this exclamation point, counter is equal to 9, well 9 is not less than 9, so it's false, and we are done. Okay, so I'm going to have these test yourself slides in the slides that you're receiving, so please use them to practice and to test yourself. For example, with this code it says how many times is the loop body repeated and what is the output of the loop. So please pay attention to these questions, understand them completely, because they might be questions on your next midterm. Okay? So, I'm going to go through 4 test yourself slides. Please, please, please pause the video. Do not put this code into JGrasp. Okay? Let me repeat. Do not write this code into JGrasp. So, the reason why I have it is so that you should actually be able to just look at it and either think about it in your head and figure it out that way, or to you can use pencil and paper and work out all the steps on your own. Okay? So after you have worked this out in your head or on pencil and paper, then you can use JGrasp to check your answer, but only after you have figured it out, because if you just plug it into JGrasp, trust me, you are cheating yourself out of learning. Okay, so please take this time right now, pause the video, and answer these questions. Okay, here is a second test yourself slide. Please answer these questions as you pause the video right now. Alright, and here is a third test yourself slide. And your fourth and final test yourself slide for while loops. Please pause the video now and try it for yourself in your head or on pencil and paper. Okay, so I really, really, really hope that you took my advice and paused the video. Alright, so the way to check your answers is to just plug the code into JGrasp. Please do not just look at the code, plug it into JGrasp right away. Alright, in addition, if you got it wrong, feel free to change up the code, feel free to change the numbers, okay? For example, it says while x is less than 10, well, you can change it to while x is less than 5, or x is less than 100, or whatever you'd like, just to be able to continuously test yourself. Alright, and if there's anything that you do not understand, then please feel free to either ask the professor that should be sitting in during our class time while I am away, or to go see the tutors. The tutors, their hours are posted on the La Lima page, so please don't hesitate to go see them. They do have a lot of availability. They're really wonderful and they can help you out and answer any of your questions, okay? So that said, let's move on to do-while loops. So a do-while loop is actually kind of the same as a while loop, except that it first executes the code in the loop body and then checks the loop condition to see if it's true or false. And of course, the loop body will be repeatedly executed for as long as the loop condition is true. But note that because the do-while loop is going to first execute the code in the loop body before then checking the loop condition, this means that a do-while loop will always execute at least once. So here is a little visual graph that you can use to think about how do-while loops work. So do-while loops iterate once. That means it's going to say do, this is your keyword, and it's going to do this statement. Do this code that is in your loop body. And then it's going to say while this condition is true, then go back and do that code again. And then look at the condition. And while it is true, go back and do that code again. And then check the condition again. And if this condition is true, well, let's just say it's false so we can get out of here. So we get out of the do-while loop and continue on with our code. So this is what a do-while loop is going to look like. We write do. Do is our keyword. So when you write do, it's going to think you're trying to write a do-while loop. So do, open curly brace. In here is where you're going to write your loop body or your code to repeat. And then close that curly brace. And then we write while and our condition. Okay, so it does seem a little weird, but do remember that our program flow is from top to bottom. Our Java is looking at our code from where we start, and it's reading down. Okay, it starts from the top, goes to the bottom. So what it sees first is this do, and what it sees next is this code. So it's going to do this code, and then it will see while and your condition. So it's going to do this, and then it sees this, and then it checks that condition. Okay, so this is why the loop will always repeat at least once, because it's going to do this and then do this. Even if this was false, this part was already done, so the loop ran at least once. So another test yourself slide, just one for do while. Where do the following loop components go? We have our initialization expression and our modification expression. So just as a reminder, in the while loop, we had our initialization expressions here, and this worked as our modification expression that would eventually make this thing false. So test yourself, figure out where the initialization and the modification expression go. If you're not sure, then just go into JGrasp and write out your guess. So we're going to say do this thing while what was our thing? Counter is less than limit. Okay? And then put in your initialization expressions and your modification expressions wherever you think they go. All right? And if you have questions, of course, see the tutors. Okay, so now that we've learned about both while loops and do-while loops, let's talk about the difference between them. Well, basically the difference is just that a while loop and a do-while loop have a different order in which this condition over here is going to be evaluated, and the order in which the loop body is executed. So just remember that with a do-while loop, we do this, and then we look at this, and if it's true, then we do this again, and then we look at the condition, and if it's false, then we're done. Okay, so use a do-while loop if you have statements inside the loop that must be executed at least once, okay, because that's what a do-while loop is going to do. Alright, so having gone over while loops and do-while loops, let's look at for loops. So for loops are actually just a more compact version of while loops. It still has all the same loop components. It has your initialization expression, it has your condition, it has your modification expression. The only difference is that all of these things are written on one line. And so any for loop can actually be converted into a while loop, and the other way around, a while loop can be converted into a for loop. So first of all, let's look at how for loops work. What we're going to do is we're going to have some sort of initialization, and then we're going to look at the condition, and if it is true, then do this thing, and we update with our modification expression. And so if that condition is still true, then we're going to do this code in our loop body, and then update with our modification expression, and then check the condition again. Let's just say it's false and get out of here and continue on with the rest of our code. So this is what a for loop is going to look like. So you're going to initialize, you're going to have your condition, and you're going to have your modification expression. So of course there's also our little open and curly braces, and please of course remember our Java coding standard: code in your loops must be indented. Okay? In addition, just know that whatever is written here is going to keep looping, it's going to keep repeating as long as this condition right here is true. So if you'll notice, it has the same three components as a while loop. It just uses a for loop and puts it all in one line in the parentheses. Okay, so there's another way you could think about these, just have some alternative terms in case you might find this to be simpler or more descriptive, whatever you'd like. So here we have our for, and we're going to say we have some sort of initial action. Okay, so this is like our initialization expression. Okay, and then we're going to have the loop continuation condition. So this is our condition that determines whether the loop is going to continue. And finally we have our action after each iteration. So usually you're going to have your modification expression here. You can have other things, but for now just think of this as a place where you're going to put your modification expression. There are other options, but I'll be showing those to you in class. Just for now, just understand that you're going to be putting your modification expression here, and then we have our loop body, and we close out our for loop with our braces. Okay, so know that a for loop generally uses a variable to control how many times the loop body is going to be executed and when the loop terminates, and we call this variable a control variable. Okay, so just another look at this for syntax with the alternative terms. So we're going to say for, and we're going to have this thing, and this is going to initialize that control variable. Okay, and then over here we're going to test whether the control variable has reached its termination value that we set, and then over here we're going to increment or decrement the control variable. So let's look at what that should be like. So this is similar to the while loop that we had. So if you'll remember, we said while this thing, while counter is less than limit, then do that. Awesome. Okay, and here we have 1 and 3, and we want our string back that says hello. Okay, so remember how we wrote our while loop like this? Well, this for loop is actually the exact same thing. Okay, we're going to say that, well, we have our variable counter, we have our variable limit, and we're going to say that counter has a value of 1, and we're going to say our condition right here is that counter is less than limit, just like here, same condition, and our modification expression, counter plus plus, we put it right here. Okay, so here we have our while loop, and if we're going to run it, it's going to give us an error, of course. Okay, so let's run it, and it just says hello, hello. Let's put some lines between there. Okay, so our code is going to say hello and hello, but let's try running it with a for loop instead. Okay, so we're going to say for, and we're going to say counter is going to start at 1, and our condition is that counter is less than limit. We're going to ask each time, is counter less than limit, true or false? And our modification expression, so each time the loop runs, we're going to increment the value of counter by 1. Okay, make sure you have your opening curly braces, and then if the condition is true, if counter is less than limit, we're going to print out hello. Okay, so this is the same exact thing, so we should expect the same exact output. Let's try. And indeed, we do get the same output. So this is our for loop output, this is our while loop output. They're the same. Okay, so just remember that you can actually write these two either as a while loop or as a for loop. Okay, so let's look at this example. So we're saying for counter is equal to 1, so long as counter is less than limit, then print hello. Okay, and so for our modification expression, remember that we can always use increment or decrement operators. So if we try that, we're going to say counter is equal to 1, is 1 less than 3, true, print hello. And then decrement counter by 1, so now counter is equal to 0, is 0 less than 3, yes, print hello. And then decrement again, counter is now equal to -1, is -1 less than 3, true? Well, yeah, but notice this is just going to keep going on and on and on, because even though we do have a modification expression, well, that's still going to give us an infinite loop. Ta-da! Here we go, forever and ever and ever. Okay, so even though we do have a modification expression and it's completely legitimate, we can increment or decrement counter, it can go either way. Well, just note that whenever you're working with loops, there's always the danger of having an infinite loop. Okay, so that's what's happening here, because counter is just going to keep getting smaller and smaller and smaller, and it's always going to be less than 3. So it's just going to run forever, all right? So please be aware of the possibility that you might have an infinite loop. All right. In addition, think about this. All right, we're going to say, well, our counter is now equal to 100, and we're going to test, is 100 less than 3? And if so, then run this, and then decrement counter by 1. Okay, so counter is equal to 100, and limit is equal to 3. Is 100 less than 3? False, so nothing happens. It's false, so it skips all of this and goes on with the remainder of your code. Okay, so let's run that. And look, nothing happened. It didn't print out hello because this was false, so this never is going to happen. Alright, so one important thing to know is that it's actually possible to both declare and initialize an increment loop in the for. So remember, our control variable, this is our control variable, okay? This is the thing that is controlling this whole for loop. We decide that counter is equal to 1, and then we look at the value of counter, and then we change the value of counter. So counter, in this case, is our control variable. But what we can do with for loops is that we can actually declare that variable. So instead of this thing right here, we can declare that variable right in that for loop, okay? And instead of using limit, well, we know limit's 3, so let's just put 3. And instead of using this string that we made, let's just print out hello. We don't need a separate string for that. Okay, so this is now our entire for loop. Instead of having all of this extra stuff out here, we can put it all in our for loop. We're going to declare initialize counter equals 1. We're going to say is counter less than 3, and then we're just going to print out our string hello. Okay, so one thing to remember, the variable counter right here, or whatever you want to call it, I or number, whatever you want to call it. So because we are declaring this variable inside this for loop, it will only be viewable within the loop. This means that you cannot say system.out.println counter, okay? Because counter is in here. Counter is only for the for loop. All right, so we'll actually go back to this idea later in the presentation, but just keep this in mind for now that you can only use this counter variable for your for loop. Okay, if you try to put it here, it's not going to have any idea what you're talking about. Okay? All right, so now I'm going to give you another set of test yourself slides. Please take the time to pause the video and test yourself. Okay, so pause the video now. All right, and here is your second test yourself slide. What are the 3 parts of a for loop control? If a variable is declared in a for loop, can it be used after the loop exits? And write a for loop that prints the numbers from 1 to 100. Okay, so before you move on, do not go past this slide until you are able to do this, okay? Write a for loop that prints the numbers from 1 to 100. All right, so first of all, let me give you a hint. We're going to say we have a counter, and we want to print until 100. So let's say we start a counter at 0. We want to go to 100, so it's going to count 0, 1, 2, 3, 4, all the way to 99, so that should be 100 times. And we want to go up, of course, to count 0, 1, 2, 3, 4, 5, 6, etc. And then, how do we print the numbers? Well, let's see, you want to start with 1, but we're starting at 0. Well, we could either just cheat and change this like this, or if you want to stick to 0 and 100, then go ahead and just add 1 to counter. So counter plus 1. Okay, so be sure you're able to understand that and how to write this sort of for loop. Okay, it's very important. Do not go past this slide until you understand how to do this. All right, please ask the tutors if you need help. Ask the professor who should be sitting in during our class time in case you have questions. There's a lot of resources available. Please do not move past this until you are ready to answer this question. And likewise, if I say write a for loop that prints the numbers from 23 to 41, know how to do that as well. Not just 1 to 100, but any numbers I give you. Because it might possibly be a midterm question. So please understand how to do this, okay? All right, so here is the third test yourself slide. Pause the video. And finally, you have your fourth test yourself slide. So I'm actually going to work through this with you just so you understand what the question is asking. It asks in terms of n. Okay, so if you notice, there's no number. In our for loop, we were saying, is counter less than 3? Well, here we just have n. So we're just going to talk about n. How many iterations are in each of the following loops? Okay, so what we're doing is we are saying in this loop, which we can do together right now, we're going to say int x is equal to 0. So x is equal to 0. 0 is less than n, and assume n is not 0, maybe. Well, x plus plus. Okay, so you can either just think about this in terms of n, or you can, if it will help you, you can substitute a number for n. Okay, so for example, let's say that n is equal to 3. So what we're going to say is x is 0, n is 3. Alright, so is 0 less than n? True. So we're going to do our first iteration. And then in here we're going to say add 1 to x. So now x is equal to 1. And then we're going to ask, is 1 less than 3? True. So this is our second iteration. We're going to do this code, which is to increment x by 1. And so now x is equal to 2, and we're going to say, is x less than 3? Is 2 less than 3? True. So now we are at our third iteration. Okay? And we run this code and it says to increment x by 1. So now x is equal to 3. And we're going to ask, is x less than n? Is 3 less than 3? Well, false. No. So we're done. We're done with this loop. We're out of here. Okay? So how many iterations was that? That was 3. And n is equal to 3. So in terms of n, there are n iterations in this loop. Okay, so I'll leave the rest, the other 3, for you to do on your own. If you are confused, if you don't understand, if you just want to check your answer, you can either use JGrasp to check your answer, or if you have questions, please go see the tutors or ask the professor if you have any questions. All right? Okay, so now that we have gone through for loops and do while loops and while loops, let's kind of look at the differences between them. All right, so basically you want to just use the loop statement that's most intuitive and comfortable for you. As we said, these for loops, do while loops, and while loops can actually be kind of interchangeable. We can write things as a while loop or as a for loop, and it'll do the same thing. But in general, a for loop should be used if the number of repetitions is known in advance. For example, if I tell you to print hello exactly 100 times, then we're going to say something like for int I is equal to 0, and we're going to say print hello 100 times. Okay, so that gives us system.out.println, and we're just going to say hello. Okay, so this is the code that's going to be executed, etc. Alright, so that is an example of when we should be using for loops, because we know we only want to print hello exactly 100 times. Alright? Whereas with a while loop, you could use this if you actually might not even know how many repetitions you need. So sometimes, especially if we have like user input, users, can always be the one to determine these things, or there's other situations where you just don't have an exact number. You don't know in advance how many repetitions you're going to need, how many times you need the loop to be repeated. So in that case, you could use a while loop. And then of course, a do-while loop can be used to replace a while loop if the loop body should be executed before the condition is tested to be true or false. Okay, so I highly encourage you to take these 3 different loops and try them all out. It will in time become more intuitive. You'll kind of learn in which situations you know you want a for loop, or in which situations you know you want a while loop. And that just comes with practice. So please do practice creating loops. Have them do whatever you want. They can do math for you. They can print little messages for you. But just make sure you're comfortable with all 3 of them and you understand the difference between them and when to use them, or when you prefer to use them. Okay? Alright, so for the last sort of section for this lecture, we're going to be going over some loop concepts. So to begin with, this is just a review, but when we talk about evaluating the condition with your for and your while loops, these things are going to evaluate the condition before your code is run. So it's going to say, is this thing true or false? If so, then run this code. Okay, so your condition might be false to start with. Okay, so that may or may not run code at all. So for example, we'll take our while loop, and we'll use these things. Okay, so we're going to have while counter is less than limit. Well, actually, let's just say while counter is greater than limit. Well, 1 is greater than 3? No, false. So this is false to begin with. So whatever is in here isn't ever going to run. It's going to say false and move on. Okay? On the other hand, we have our do while loops. So this is going to, just as a reminder, evaluate the condition after running the code. So what that's going to look like, it's going to say, we're going to see do this thing, and we're going to say do, I don't know, system.out.println hello. Sure. And do it. Okay, and do it, and then check our condition. Is counter less than limit? Okay, so as a reminder, it's going to evaluate the condition after first doing this. Okay, so we're going to do this thing and then check the condition. If it's true, do this again, and then check the condition and do this again, and then check the condition and do this again if it's true. And if it's false, then we're out of here. We're out of our do while loop and we continue on with the rest of our code. So just know that with for and while loops, they may or may not even run code at all, whereas with do while loops, you know your code is going to run at least once. Okay? In addition, know these terms, counters and accumulators. So we have counters. Basically, a counter is just a variable that is used to keep track of counting. So, for example, when we are writing our for loop and we say counter is equal to 0 and counter is going to go up to, I don't know, 99, and we're going to increment counter. Well, this counter is this counter variable, which we just happen to call counter. We can call it I if you would like. I and I. Okay? So this variable is a counter because it's going to keep track of what point in the iteration, like how many times this thing has looped through, that you are in. Okay? In addition, we have something called accumulators. Basically, it's just a variable that is used to keep track of a sum. So it's actually kind of the same syntax as a counter, because remember, this thing right here, we can write it as counter is equal to counter plus 1, because we're just saying take this value of counter and add 1 to it. Well, the same thing. Take that value of counter, add 1 to it, that's the new value. But the difference is that accumulators are typically not 1, and usually instead of 1, you might be adding some other variable to it. Like instead of a hard-coded number like 1, you might say, well, the variable x, add some variable x to that. So that's the difference between counters and accumulators. Usually we use them to keep track of some sort of sum. And so let's see, we also have something like sentinel values, and these are a special input value. We specify in our code that if we have this value, this signifies the end of the input and is used to terminate a loop. Okay, so let's go over what that is going to look like. Basically, you're going to be using some value that is outside the range of your valid input. And so having this sentinel value, it guarantees that your loop will eventually terminate. It guarantees that you have some way to get out of the loop and you're not just going to be stuck in the loop forever. Okay, this is also known as a flag value or signal value. For this class, I just need you to know that's called a sentinel value. Okay, so let's actually create a program that uses a sentinel value. All right, so we're going to create a program. Let's see. How about we are going to create a program that asks the user for a bunch of numbers and then returns the total sum of all the numbers they gave us. Okay, nothing too fancy. So let's just, we know we're going to be taking input from our user, so we're importing our scanner, and we're going to create our scanner object. So let's call it, I'm just going to name it input, and I'm going to say new scanner system.in. Please be sure you can memorize this. It might be important in the future. All right, so we're going to then ask our user, enter an integer, let's say input ends if you enter 0. Okay? Alright, so that can be print. Alright, so then since we're asking them for input, let's make sure we're able to store that input. We're asking for an integer, so we're creating an integer variable, and we're just going to call it data. And so we use our scanner object, which I named input. And because we're taking an integer, we say next int. Okay, and then let's just initialize our variable sum, and we're going to say while whatever they give us, whatever number they give us, is not equal to 0. All right. We're going to add whatever and start doing our little addition computation. And we're going to keep asking them for numbers. As long as they don't give us 0, we're just going to keep asking them to enter an integer. Let's just say, give me more integers. Okay. And then whatever they give us, we're going to store it in data, our variable data. Input is the name of our scanner object right here. And then, because it is an integer, we're going to say next int. And then, let's see, we are done with our while loop because, yep. And then at the very end, let's say they write 0. So after we're done summing up all the numbers, we're going to say the sum of all your numbers is, and we're just going to print that sum. Okay, so let's see if this works. Alright, here you go. Enter an integer. Input ends if you enter 0. Well, let's try putting 0. And we're out of there. It just gives us this end part that says the sum of all your numbers is 0. Well, because we didn't give them any numbers. Alright, let's try running that again. So, we're going to enter an integer. Let's say 2. Give me more. Here, have this. Give me more. Here, have this integer. Okay, I'm bored. Let's just finish the program. Alright, so the sum of 2 plus 3 plus 4 is 9. Okay, so here our sentinel value is 0. So basically, we set it up so that if the user types 0, it exits out of this while loop and we're not stuck in it forever. Okay? Alright, so we also have nested loops. So just as with if statements, a loop can be nested inside another loop. So remember how we had if statements inside other if statements, or if else statements nested into other statements. So what you can do is do the same thing with loops. Alright, you can nest them into each other. But you must know that each time the outer loop is repeated, the inner loops are going to be re-entered. So what does that mean? We're going to try this out. We're going to say 4 into I is equal to 0, I is less than 10, I plus plus. Okay, this is our for loop. And we're going to say for int j is equal to 0, j is less than 10, j plus plus. No, let's just say I. That's fine. And I plus plus. Okay, so we're going to print out. Alright, let's see. What should we print out? So let's close for loops and make it pretty. Alright, so here, let's actually print out what the value of I is. Okay, we're going to say I is and print out I. Okay, this is so that we can see what the value of I is. And likewise, over here, we're going to say I is something. And then we're going to say, and j is okay. Let's just put a little more space, and let's try running it. And of course, we have an error. Alright, so I'll give you a second to look at the code and see what happens, or what went wrong. Okay, so if you don't see it, I accidentally put an I there. So this should be j, because we're incrementing j, otherwise it just keeps incrementing I forever. Okay, let's run this. Alright, this looks much better. So, here's what happens. When I say each time the outer loop is repeated, the inner loops are re-entered. Okay, so we're going to say 4 int I is equal to 0, I is less than 10, I plus plus. Alright, so we're starting with I is equal to 0, 0 is less than 10, true. So run this code. I is 0. And then we say, let me move on to here. For j is equal to 0, j is less than I, j plus plus, we say j is equal to 0, is j less than I, is 0 less than 0? No, so nothing happens. Okay, then it goes back to here. So we say I plus plus now, so I is equal to 1, is 1 less than 10? True, so we're going to print this. I is 1, right here. I is 1. Okay, and then we move on to here. For j is equal to 0, is 0 less than 1? Remember that I is now 1. So is 0 less than 1? True. So now we're going to do this. I is 1 and j is 0. Okay? And then it increments j, so j is now equal to 1. And then we're going to ask, is 1 less than 1? So remember that j is 1, I is 1. Is 1 less than 1? False. So we're done with this loop, and we move out of it, and then we increment our I. So I is now equal to 2. Okay? And we're going to say, is I less than 10? Is 2 less than 10? True. So we're going to say I is 2, right here. And then we are going to then move into our second for loop, our inner loop. So we say j is equal to 0. J is 0 less than 2. Remember the I is 2. Is 0 less than 2? True. So we're going to say I is 2 and j is 0. And then we do j plus plus. J is now equal to 1. Is 1 less than 2? True. So now we're going to say I is 2 and j is 1. So that's right here. And then we increment j by 1, and j is now equal to 2. And we ask, is 2 less than 2? Remember that I is 2. Is 2 less than 2? False. So this doesn't happen. We're out of there. And then we increment I. I is now equal to 3. So then we ask, is 3 less than 10? And it is. That is true. So we do this, etc. Okay, so let's just skip ahead. All right, so say we're at if I is 9, is 9 less than 10? True, yes. Okay, so it's going to say I is 9, and for here, just remember the inner loop is re-entered. So what that means is that j is going to start at 0, and it's going to increment each time. Okay, I doesn't change because I over here is 9, and it's just going to keep running this loop until it finishes. All right, so please understand this idea of nested loops. Understand how this thing works, where it says each time the outer loop is repeated, the inner loops are re-entered. Okay, so if you would like, you could copy this code right here, say, and use these system.out.println I is, and say I is and what j is, because it's actually showing you all the steps that the loop is going through. So every time your loop goes through this one, it does this, and then when it does this loop, it does this. Okay, so that's really helpful in seeing each step that your loops are going through. All right, so now that we've gone over nested loops, I must warn you that a nested loop can take a really long time to run. So, for example, if we have this, it says we have 3 nested loops. So we say for int I is equal to 0, I is less than 10,000, I plus plus, and then we have another loop, and we have another loop that goes to 10,000, and then in this loop we're going to perform some action. Okay, so this whole thing, this is going to cause this code over here to be executed 1 trillion times. Okay, so even if it takes 1 microsecond to perform this action, and note that 1 microsecond is 1 millionth of a second, so that's totally plausible for a computer to be able to do this code right here in 1 millionth of a second, because computers are super fast and awesome. But even if this code right here only takes 1 millionth of a second to perform this action, because it is nested within these loops, which go on until I, j, and k hit 10,000. This loop will actually run for 277 hours. So if you would like to play with these loops, just be aware that maybe you don't want to do this. All right, so keep your numbers small just to save yourself some time. All right, so this is our final concept that we will be going over for this lecture. It is something called variable scope. All right, so don't worry, we're almost there. A variable scope is where a variable can be used in your program after it has been declared. Okay, so basically it depends where a variable is declared to determine where it can be used. So I am actually still getting people asking me for help because they are getting errors in their program and they say, I don't know what's going on. Why can't I do this? I want to print this code that says hello. Remember our string hello? I want to print it. Well, Java's reading your code and it's like, sure, print this thing out. Hello, what is this variable? We didn't declare a variable, okay? We would need to do something like this. Declare that variable before we can even use it. Otherwise, Java has no idea what you're talking about, okay? So that is the idea of variable scope, and it becomes even more important when we're talking about loops. All right, so here's an example. Do not put this into JGrasp yet, okay? We're just gonna look at it together in the slides, and then if you would like, you can put it into JGrasp later. But let me walk through this with you so we can look at the different possibilities. All right, so here we have some variable named numLoops. It is of type integer, and we're assigning it the value 5. And then we have a for loop. In our for loop, we're going to declare an integer named I. We assign the value of 1. We say if I is less than numLoops, then print out I, and then after you print this out, increment I by 1. And then when we exit out of this whole loop, we're going to print out the final value of I. Okay? However, because the variable I is declared as the initialization expression for this for loop, its use is restricted to the for loop, okay? You're declaring it here, not out here, which means only the for loop can see it. You can use it here, here, here. You can stick it in here between the curly braces, but that's it, okay? Because if you try to run the code and you try to use I outside of this for loop, we use I right here. If you try to do that, you're going to get an error. It's going to say error, cannot find symbol. Okay, what that means is it has no idea what I means because I is in here. It cannot see I outside of the for loop and therefore error. Okay, so how do we fix this? Well, here's an easy solution. We're just going to declare the variable outside of the loop. So remember, like this, we first declared it, and after we declared it, we can use it any way we want afterwards, okay? So, for example, if we say int numLoops is equal to 5, and we say int, let's say I is equal to 0, then because we've already declared this, anything that follows after that, even if we're using it in our for loop, I is equal to 1, we're going to say keep going until numLoops and increment, etc. And then system.out.println I, and let's say the final value of I is, alright, let's see what happens. We don't need this, and we don't need this. Alright, let's see. Okay, so it's going to start at 1. It's going to go up to numLoops, so I is 1. Iterate 1 iteration, do that. I is not equal to 2 is 2 less than 5. true, iterate again, and print out 2, which is what I is, and then add 1 to I, so I is now equal to 3. Is 3 less than 5? True, so print out I, which is 3 right here. Increment I one more time. I is now equal to 4. Is 4 less than 5? True, so we're going to print out I, which is equal to 4 right here. And then increment I by 1, so I is now equal to 5. And we ask, is 5 less than 5? False. So we're out of that for loop, and we move on with our code. And we say, system.out.println, the final value of I is 5. Okay? So the reason we can do that here, and we don't get an error, is because we declared our variable before the for loop. Okay? So remember, before we had int I is equal to 1, and in this case, we'll get an error. Here, I can show you. Alright, so here is where we're declaring I, and we can use it for this for loop, but if we try to use it over here, and crash, okay? So, or error. Alright, so here is a second example, and what I'm going to ask you here, this is kind of a test yourself slide, so we're going to be looking at int I is equal to 0, okay? And so I'm going to ask you now, what is the scope of I? Where can we use this I variable? Okay, so take some time to look through it. Okay, so the answer is we can use I anywhere in our code after we declare it. So here we declare it in line 1. Anytime after that, if we want to use I here, even if it's in an if statement, that is in a try block, etc., that's perfectly fine because we declared it up here before everything else. Okay, so for this program, I is at the top level and the scope of I is anywhere after it's been declared. Okay? Alright, now we're going to look at this variable over here. It's called num. It is of integer data type and it has a value of 3. Alright, so what is the scope of num? Alright, so the scope of num is lines 4 to 7, and that is because it is being declared inside this if statement right here, which means it can be only used inside the if statement, which lasts from, let's see, it lasts from lines 4 where it's declared, so you can use it in 5, 6, 7, etc. But it must stay within this if statement because it is declared within the if statement. Alright, now try this one. We're looking at the variable x. It is a double and it has a value of 0.8. So what is the scope of x? Alright, hopefully you said 6. And so if you'll notice, this is being declared inside a while loop. Okay, so that means you can only use x inside the while loop. Alright, last one. What is the scope of the variable y? Alright, so hopefully you said line 11 because you can only use it in the catch block. This variable right here is being declared inside the catch block, which means we can only use it inside the catch block. Alright, so to avoid these problems, one simple way is to just declare all your variables at the top. Alright, so our code was something like, we can keep this, and we said, okay, let's just take it out. We said int I is equal to 0, and we also had int num is equal to 3, and we had some double x that I believe was equal to 0.8, and I think our double y was 4.5. All right, so we could just write this all out and then write the rest of our code, and so we wouldn't have any trouble using any of these things in the rest of our code. So we can use it for here, and we can use it over here. My bad. Right? And since we declared x, we can just use it over here, whatever you would like. So we don't even have to give them these things. The important thing is that we're declaring them up here before we even use them. Okay? So do try to declare all your variables at the top. You could do it like over here, but then you would have to keep track of when you can use it. So that's your choice. It's no problem. You don't get points off wherever you put it, as long as it's working the way you want it to. Okay? The advantage of putting them all up here in one place and declaring them all at the top is that it's really easy to locate them. So for example, if I want to say, well, we're using I over here, but if I declare it up here and I say, well, I is 1. Okay? So now I can just change it here and it'll be set over here. In addition, I highly recommend that you follow our Java coding standard. So please do not do something like this. All right? Basically, if we're trying to write our code like that, we're going to say catch and catch some exception that we're just going to call E or whatever. And we're going to say we're declaring our double y, which is going to be 4.5, etc. Well, if you're going to write your code like this, well, first of all, it's points off on your assignment. So I hope that's important. But just as important, if not more, is that your code will be really hard to read. It's really hard to see or to figure out what the scope is if you're just writing things like you're declaring variables over here and you're like, well, is this in the while block or while loop? Can I use it over here? It's just hard to read. Okay, so please do follow the coding standard. Your code will be so much more organized and it will be easier for you to determine the scope of your variables. Okay? So I hope to see your code properly formatted like this. And of course, when you indent your code properly, it's clear where the code is nested. So it's easy to see that there's an if inside the try, and there is a while loop inside the if statement, which is inside the try, etc. Okay, so that is all I have for you today. Thank you so much for watching. If you have any questions, please do ask the tutors. They are here for you. They have a lot of hours available, and they're really fantastic, great at explaining things, etc. And there should also be a professor sitting in the classroom during our regular class time, so please also ask him or her. Okay, so that wraps up our lesson on loops. If you have any questions, please ask the tutors. Otherwise, do get to work on your assignment, and when you're done with your assignment, you can move on to the week 8 slides.